So today we are going to solve Codeforces problem of difficulty level 1500. Okay, so I'm solving these four problems: 16, 1659 to 1630. Okay, this is the first problem. You are an ambitious king who want to be emperor of the reals, but to do that, you must first become empire of integers. Okay, consider a number x is the capital of the empire is currently at x0. There are n unconquered kingdom at position 0 to x and all you want to conquer all other kingdoms. Okay, and all integers are in increasing order. There are two actions available to you. You can change the location of your capital, let it be a current position is c1, and another conquered kingdom, let it is c2, at at a cost of c1 minus c2 8 times. From the current capital, let its current position be c1. You can conquer a unconquered kingdom, let its position be at c2 at a cost of, okay, if I need to conquer, then it will be c1 minus c2 into b. Okay, you can't conquer a kingdom if there is a unconquered kingdom between target and your capital. Okay, so I have to conquer all these in a line. Note that you can't place the capital at a point without a kingdom, so it is on must be on x1 to xn only. Find the total cost to conquer all capital. Your capital can be anywhere at the end. Find the minimum cost. Okay, so n will be 2 in 10 to the power 5, t is 10 to the power 3, and all test cases doesn't exist 10 to the power 5. So 10 to the power 5, so we need to do it in n of log of n. Okay, so basically what we are given, so we are just given, let's say it is a let's say it is a number line. Okay, and at every position let it be 0, and these are some values where the other kingdoms are. Let's say 1, 5, 8, 9, 15, and all are in increasing order. I need to do two operations. Can replace a kingdom or replace the kingdom at any position. Let's say it's c2, or to like to change the location of the kingdom or something replaced to c2, so its value will be c2 minus c1 8 times. That is the distance between them into 8 times. Okay, and the second one is I need to conquer a kingdom. That will also gonna cost me the distance between the my kingdom and the conquered kingdom into b times. Okay, I need to do it in minimal ways. So first of all, in how can I conquer this? Okay, so I just conquered some from this position. From, let's say I'm just making kingdom this one for and conquering these two, and after that I am let's say having some more kingdoms. After that I'm going to this kingdom, making this kingdom as my kingdom, and conquer all these, or I should conquer at a place. Okay, so the thing is, we can like what will be the minimum, what will be the optimal solution? We have to conquer from a point, like I just come up to this point. Oh, and after this I will conquer all of these. Okay, and if that will be done easily by prefix sum, so because the prefix sum will be the sum of all other because this is just an distance, so distance will be the sum of all these after kingdoms minus number of kingdom into the current position of the kingdom. That will be done using the that is will be using the prefix sum. That will be 9 minus 8 plus 15 minus 8, and so this can easily be done by prefix sum. That's not a problem. But I have to prove that which one is better. If I come to this position and conquer all these, what to say, all these kingdoms, or but and the another, this is the one, and the another is I just come up here, I conquer some of the kingdoms, and then move to this position and conquer all of these. In this case, what I'm doing is I'm just reaching at this point. This is the last point, okay? But here I'm just taking the kingdom at this one, and after that I'm conqueror of some of the kingdoms, and then moving the my kingdom. And here what I'm doing, this is my last point where I'm making my kingdom, and I'm just going with the concurrence. If first of all I just, so I need to find which of them is optimal, okay? So this is all the time we have to do. We have to find which one is optimal. We have to find which is gonna help in the optimal, which will gonna give me optimal solution. If we have two or three ways that are pop in your mind, so you have to always find a optimal one. So these I think you do all the time. So so we need to prove this. Like what I'm thinking, the first case is I first my kingdom is here, I gonna conquer this. Next time I shifting my kingdom, I need conquer this. Then next time I shifting my shifting my kingdom. Then I conquer this 8 one. Then I'm shifting this one, and from this point I'm conquering all of the other kingdoms. Okay. And the second case, you may think that this is not optimal solution. The second optimal solution can be not optimal solution. I'm just trying to figure out how many ways this can be done. Okay. The second thing is, like, we can find it up to take this position at the last position, this position as the last position. So this is a kind of brute force. But yeah, brute force it is there. But you are saying that okay, it is finishing at the eighth one. Can we do something like that? I just come up here, okay, I just conquer this kingdom, then I move my kingdom to this point, and after that I conquer this one or two kingdom from here, and then move to the next kingdom. This can be a case. So if they like, if we like, these both are kind of this kind of brute force, this, and we have to find minimum of all of these. I'm just like, what is that, I'm shifting my kingdom at the is this last position, this last position, this, and for all these kingdoms I'm shifting my kingdom at this position, at this position, and after that all the other kingdom I'm going to conquer from this position only. So this is kind of brute force. Okay, this is gonna give me result, but I need to find, can this mm, both of them, which is optimal among both, which is optimal. Okay, so you can see that if I come from, this is the last position, okay, this is the last position. So what is the a value or b value? A value is for the shifting the, yeah, the a value is for the shifting my location of the kingdom. So a value will be just, if I am going from here to this one, then after from here to here, or from here to here, and then at the last here. So value will be 0, this is 1. So the value of these values I'm just taking, this is 1, then next kingdom at 5, then 8. Okay, so total value will be 0 minus 1 1, 5 minus 1 is kind of 4, and that this is 3, total will be 8, and this is equal to, so I can say that one thing, 8 minus 0 is equal to, or let be general, it be general, not this specific. Let's say this is C1, this is C2, and this is C3. Okay, so C2 minus C1 is equal to C1 minus C3 plus C2 minus C3. That the distance this if there is any point in the mid of c1 c2, the distance from like this point to this and from this point to this is must equal to this point. This is a, I think, obvious. This is obvious, and I'm going to use this one, okay, here. So for this point, I'm clear. Yeah, so I'm saying that I'm taking this as last position, and I'm okay. So what is my value? I am shifting accordingly. When I'm just conquer the kingdom, I shift my kingdom to that one up to the which position I'm taking the last one. Okay. So the value of, so what is the cost? Let's say I'm say first I'm conquer this. So what value it is for conquering is 0 minus 1, that is b 0 minus 1 plus 1 minus 5, then 5 minus b, that is okay, this is we are taking the mode, and 5 minus 8 and b, and this is the value of conquering all these from here to here, and some value k from here. I'm just conquering all the others. And the second scenario, what I'm saying is that I am just here, I am here at 0, and I conquer from here these two, this one and this one kingdom, and after moving to the 8. So what is the value in this case? Okay, this is the b value in the first scenario. Then the, what is the value of shifting the, what is a value or value of shifting the location of the kingdom? So that one will be, I'm not going to second scenario, in this first scenario only. I'm just first conquer the total sum will be this plus the shifting the location. So that one will be, I'm first shifting to this position, so 0 minus a, then this to this position, 5 minus 1a, plus shifting to this one, that will be 8 minus 5a. So I can say that that is, I am taking out the b as a common, that 0 minus 1. So I just draw the example like 2 3 point, then it will be equal to first and last one. So I can say that it will be, for just simplicity, it will be 0 minus 8 or 8 minus 0 b plus k, and the a values are same. I'm shifting at the last is at the 8th one, that is this one. This is my value. Okay. In the second scenario, what I'm doing, I'm just here for these until these two kingdoms are conquered. So what is the value of the conquering will be 0 minus 1, 1 minus 0, sorry, b, and another will be 5 minus 0. I'm conquering from this position. Then you see that this will be coming more, okay, and then I'm shifting to, and I'm also coming, let's say then I conquer this one and this one, and then shifting, then I need to conquer this also. Let's say I conquer this also. Okay, then will be 8 minus 0. Okay, this is, and sub k value after the conquering all the others, and the a value is same. I just need to jump from here to here, so the a value is 8 minus 0. So you can see that the b value comes more because I'm not shifting the my kingdom location. So b comes, so b will be the distance from the current location to this one. So this comes more, okay. But the a value is remain same if I am shifting next to next, or I am shifting after some time. So it is always the optimal solution to shifting just if I concur and I just shifted. Okay, so it is always optimal solution. And so I just found out that it is optimal solution, that I'm just shifting by when I'm concur, I'm just shifting. So for the answer, I'm saying that from this solution I'm going to get you the answer. Okay, let me erase the second case, that will be not optimal solution. I just prove that. Then I need to find like what will the value. So I'm just saying that we are just using the brute force at every position. There are n positions, so I'm come up, okay, first I'm coming to this one, I'm conquering from shifting to this position, and for all I'm conquering from this position. Then I'm coming to this one, uh, just currently shifting, shift after, and then conquering all the remaining from this position. Same here, same here, same here. Okay, then I need to find what is the minimum solution from all of these. So the value will be the same. If I am at this position, let's say this is the I position, then it value will be 0 minus the value of x of I into b plus, let's say the value of the shifting will be x of I the same minus 0 into a. Now I need to conquer from this point all the other, all the remaining kingdoms. So what will the value? So value will be, I can say, for this, in this scenario, 9 minus 8 b plus, what is that, 15 minus 8 b. So I can easily say that these are kind of increasing values, so I don't need to put the absolute value braces. Okay, so I will say that 9 minus 8b, I'm taking the b out from for all these values because b will be common. I'm concurring from this position. Okay, so 9 minus 8, 15 minus 8, so I can say that that will be equal to sum of all the elements minus number of elements into 8. This is the current value. So I can say that if I need to generalize this in terms of I, that will be the sum of all elements, that is a prefix sum from n minus 1 to this position minus number of element, that will be n minus I minus 1. Yeah, that it. And that will be the current value, of x of I into b. I can say that using this value. Okay, yeah, so the result will be this one, this plus this. Yeah, here we go. So I think you getting some senses. Okay. It is a kind of good problem, not a good, very good, but it is okay. So let me write the solution for this. Let's go together. If you know, really understand this, so let's code by yourself. So I have a b and n a b, n a b, then c n a b. Okay, after what I am having x, and I need to take a vector of 15 of x value, sorry, x of n, then 4 into x plus y less than n I plus c in x of I. Okay, now I'm just shifting my location from 0 to n I plus for all of these. Okay, let's say n plus 1. So if I am at the my current location, that is 0 location, what will the answer? Answer will be, okay, first of all I need to get out the all the sum. Let me see, is 10 to the power 8, 10 to the power 8 and 10 to the power 5. That will be long. I require long. Sum of all the kingdoms will be sum, oh my god, sum plus x of I, sum plus x of I. Then answer will be, what happened to this? God man, oh, this is not the same variable. Answer will be, what will be the answer? Answer will be from this position to the last position. So what will be the answer? Sum, total sum minus number of elements. Total sum will be sum, number of element will be n. I need to conquer. If I am at 0th position, x of I is 0, and into b, I say 1 long into b, that I want to know. Yeah, then there is no need to write the 0, by the way, if it is okay for type of understanding. Now I'm shifting from my each location, so the current answer will be, what I need to do, 0 into x of I into b, I need to be 1 long, same for x of I into a, and will be the sum. So if I am at this position, then I need to subtract my sum of this position. Okay, and now the sum will be remaining all of the kingdom that is towards the right of this current kingdom, and the value will be total sum I have, and I need to subtract number of kingdom remaining. If I is equal to 0, then will be n minus 1. Yeah, good. and that is x of I and into 1 long into p. I will say my result answer will be the minimum of the this result and 10 answer, and just output the answer. Okay, so let me check out for these example or test cases. I don't think so it is good. Oh, it is good. By seeing this value I thought it is not good. So let me check, it will be long at any position, not TLE. Sorry, out of border, out of border, yeah. So overflow situation it will gonna give me. Let's see, it is good. Oh yeah, fine, perfectly fine. Okay, the second problem. So we have, there is a classroom with two rows of computers. There are n computers in each row and each computer has its own grade. Okay. Computer in the first row has grade A1 to AN and the second will be same B1 to BN. Initially, all pair of neighbor computer in each row are connected by wire from I to I plus 1. Okay. So only two rows form two independent computer networks. Okay, yeah. A and B. Your task is to combine them in a one common network by connecting some or by one or more pair of computer from different rows. Okay. Connecting the ith computer from the first row to and the jth computer from the second row cost ai minus bj if I am connecting ith and j. Okay, you can connect one computer to several other computers that need a program. Okay, but you need to provide at least a basic fault tolerance. That what is, you need to connect computer in a such a way that the computer stay connected despite one of its computer failing. Okay, if one is broken then the system will be working, the minimum cost. Okay, so first of all what we are given just two lines. Okay, I will say these two are the values. So not values, these two are a and b, the computer networks, so each computer are connected. So in how many different ways I can connect, so that there will be, if there is a circle. Okay, let me see. uh, let's say if this is a circle. Okay, if this is a circle, if there is some fault is there, like this is the fault, then this is cut off. This, if this is cut off, then all these are connected. Okay, like if this is cut off then the scenario will be something like that. Yeah, but all of these are connected. Okay, all of these are connected, so I need to form the circle. In how many ways? Okay, let's go. The first of all, let's say form the circle. This is the way. This is the first case. Okay, I need to make it little bit smaller so that all cases can be in this. Oh, what man? It is not erasing. This is type of bullshit. Okay, now it is good. So first of the case is, so what I need to know, sorry, what I need to do is I need to make the circles. So if there is any problem, so all will be connected. This is the first case. Second will be, they can be connected something like that. Third will be, let's say this may be not be its minimum value. Its minimum value lies from this point to minimum point, that is this point. So this value, like, so what I'm trying to say is its a value is 5, so all values, so minimum value, so this can connect to this one is, let's say this is also 5, it is 0. So this is the kind of the minimum one. Okay, so I connect it to its minimum one, and similarly for these, and I connect making a circle, so all will be connected. So if any will be folded, let's say if you say this is folded, then all these computer will be gonna feed by this one, and all of these are connected by this wire, and all these are in a circle. That's not a problem. This is the third scenario. Okay, The fourth scenario will be the same. Okay, I know that, man. What's going on? Okay, if I connect this to this one, and this is the fourth. Anything else? If these are connected, okay, this one is also can be possible thing. Like this is connected to its minima, and the another is connected to this one, and this is connected to this its minima. So these points are its minima, the minimum value which can be. Okay, so now say if this is defaulty, and if this is defaulty, so these are connected, these are also connected, all of these are connected. Yeah, this can be a scenario. And similarly, if this one connected to its minima, I'm just, these are the reverses of each other. Okay, these are the just reverses of each other. This connected to its minima, and this connected to this, the last one, and this connected to this minima. So all will be connected. So okay, so this is the 6 possible ways. Okay, so we need to just, these are the, I think these can be, yeah, these are only. Okay, so now what I need to do is I need to just find, so what I need is these are the simple a naught, b naught, and this is an minus 1, this is the last component. So these can actually done by these 4 values, and we already know these 4 values. For this we need to find the minimum of this one, the minimum of this one. So I need to the minima that will connect from here to this position. Okay, that's it. I think I am good to go. So let's code together. So we just need to find the minimas. Okay, like from this position, if there anything, so I where it has the minimum value, that is ai minus bj, the minimum value. Okay, this will, it is so this will gonna erase. Okay, it is not. Okay, here we go. Let's code this. Okay, so what I'm giving n a c n vector of a of size n, d of size n. I need to find the minima of a1, minima of a, let's say the last one, minima, these are b1, and minima of b2. And also let's say answer for this is, first of all I need to take both the arrays. For I is equal to 0 less than I plus c a of I. First of all the a of I. Okay, then I need to take b of I. Okay, now the answer for these two cases is just an minus bn, that is the minima of, the first one is a of I minus, sorry, a of 0 minus b of 0 plus absolute value of, this will be a mess. I will say I will use the ABB, absolute value of A0. I will create a function that will be good, otherwise taking the here ABB, A of n minus 1 to and B of n minus 1. So I'm creating a function, otherwise there will be a mess of taking absolute value here only. So it will be int ABB, that will be A, and AB will gonna return absolute value of A minus B. That's it. Okay, this will be the, this condition is done. Now we have to look after A is connected to a node connected to b of n minus 1 plus a of n minus 1 connected to b of 0. Okay, from these two values I'm gonna take this one. What happened, man? Oh. Yeah, here we go. What? This here, okay. After that I need only one. Okay, wait, another thing. Okay, here we go. Okay, we are good to go. So I need to find for int I is equal to 0 less than n I plus plus. So minima of 1 is equal to minima. Oh man, I need to find that is a0 with any value. So abb with this one, a0 and with, let's say, b0. Similarly, the minimum value of a of n minus 1, a of n minus 1 with any value. So I'm taking for the first one, that is b0. Same case here, abb of a b0 with any value, that I'm taking a0. Same case here. Now it clearly visible. Will be abb for b of n minus 1 comma a0. So actually I need to find these all. Okay, so minimum of a will be minima of a, the abb value from a node to bi. Okay, now minima of a2 is equal to minimum of 2 absolute value of a of n minus 1 and b of, what is it, with b of I. Okay, same now two values for the b, that is b1 b2. b1 b2, I need to just b0 to any a and b of n minus 1 to any a. Here we go. So now answer will be just a minimum of answer comma. Now how need I this one, if I'm just going with this one, shit. Yeah, here we go. So a node connected to b node, that is abb, a node connected to b node and plus a double b, sorry. And the another case will be minimum of n minus 1, that is minimum of n minus 1 will be a2, minimum of a2 plus minimum of a1, minimum of b2, sorry. Okay, second case can be a node b node, no, an minus 1 bn minus 1, an minus 1 bn minus 1, then a1 b1. Okay, another case will be this one. So a node connected to bn minus 1, a node connected to bn minus 1 and this b1, minimum value of b and minimum value of a1, a of n minus, that is a2. So don't think like this is kind of taking minima and whole. Is not a value. Okay, and b2 and a1. So you can do it by any yourself. By the way, this is not a great deal. Okay, I need to find that is giving the right answer, or did I miss any cases? 37. That's so no, it is not. I missed some cases, but the second one is giving me something no else. Will take a long. It will be more beneficial. Yeah, here we go. We are taking long now. Oh, and a not b not. Okay, I need to find long. That is the best use of function. So I need to change only 3 value. Otherwise, I have to check all the. No, I don't need to change. 19998. Is that so? Yeah, it is good, but this is not giving me correct value. So what is its value? It is saying that computer 1 is connected with first row with computer 2. Computer 1 from first row is connected to computer 2. That is 3 value. Okay. And computer 3 is connected the first row of computer 2. Okay, let me see it. Okay, let me make 2 computers then. 110.1. What 110.1 is? A1, A2, and the grades of computer in the first row. Okay, these are, oh man, 110.1 and another is 24.25. 24.25. Okay, so its minimum value here, it's connected to its minimum value, or this connected to its minimum value, this connected to its minimum value. Oh yeah, I missed this case on one. What if both are connected to same one? Then these are connected to this one. If this is fault, then this is working fine. Let's say I'm saying thinking like that. Okay, if I connect the minimum of both is same, let's say, and here is both is same, and this computer is gonna not gonna work out, this is gonna be faulty. So is that all are connected? I think so. These are connected from this way, these are connected. Yeah, everything are connected. So I just missed this case. So sorry for that. I need to write up one more case. There are 7 cases. Okay, or maybe more. Let's see. That will be the minima of 1 plus minima of a1, oh, a1 b1, a1 b1, a2 b2. Yeah, here we go. What happened? It is 31. What is the answer? Is 31. Yeah, here we go. Let me check with the, let me submit this. I think this gonna work, or we forgot some of the cases. Oh yeah, we cover all of the cases. So okay, so factorials and power of 2. So this is third problem. So a number is called powerful. It is a power of 2 and a factorial. In other words, the number m is powerful if there exists a non-unique, non-negative integer d such that m can be 2 to the power d, or m can be a factorial of d. So in particular, these for example 146 are powerful numbers. Yeah, for one, you are given a positive integer n. Find the minimum number k such that n can be represented as sum of n distinct powerful. Okay, so what we need to do is, so we are just given any m number. So what is the range of m? M range is 10 to oh 10 to the power 12. So m we have to represent some factorials is equal to sum of some factorials. Okay, plus 2's power something, 2's power n or something. Okay, we need to represent m into these summation of the both two. So let me see how many factorial can become 2's power 12. So the factorial of, let's say 40, maybe 40 is, oh, 10 to the power 47. Then let's say 20, 10 to the power 18 still greater. Let's say 15, yeah, 10 to the power 12. Then it is okay. 15 is okay. So we get a range. So now you can see that m is very large. Yeah, m is very large, that is 10 to the power 12. But range of factorial can be factorial 1 to factorial 15 only. There are only 15 possible condition. So we can easily use like, so like taking of any of these. So any like taking of any scenario of like how many different ways I can select some of these, that is 2 ki power k, and 2 ki power k is 2 ki power 15, and that is 10 approx 10 to power 4, 10 to power 5. So I can use easily. Okay, and how to know about, if let's say if a number is remaining from factorial, the number is remaining, let's say 12 number is remaining, then how many power of n is required? Okay, so this is same thing like to bits. So 12 can be represented 8, 4. So yeah, every kind number can be represented in a form of bits. So 2's power 4, that is 2's power 3, sorry, my bad. 2's power 3 and 2, 0, 1, 1, 0. So every number can be represented as 2's power 2 in the bit form. So actually after that, after we are just taking some values of some factorials, okay, and then the value and the point comes to, we have to need to find out how many twos, different twos power gonna make this value. So we are just gonna count the number of bits set, number of bits in the array. Yeah, simple. So mainly we have to focus in, this can be done in log of n, that is very simple. So for 2's power log of uh, what is that, 1 power log of 2 of 1 e की power 15 12, sorry. Oh, so approximately 40. So that is approximately 40, so very small. We don't need about, we don't need to have, we don't have to worry about the like what is say TLE, because this is very small, this is 40, and this is also small, that is 15. Let's do it. So how can we do it? So for the that one, taking the 2's power is very simple. Okay, we just need to count the bits. Now the problem is how we have to make, we have 15 factorials, like factorial 1, we have 15 values by the way, up to 15. We have to output some of, we have to take some of the values, let's say this and some these, and then some 2's values, like that, let's say 2's power 3, 4, that can easily done by bits. Now we have to take these values, how can we do it? So there can, and is very for this, in case the value, the number of these values are very small, that is 15, I need to take, so different, if I consider all the scenarios in how many ways I can take, that is 2 ki power n, that is 2 ki power 15. It is okay. Okay, so we are just going to take out all the scenarios, and if it's some, let's say n is 15 and its sums come out 10, after taking sub scenarios, all the scenarios, the value is 15. Not for the some scenario it is 15. So I'm gonna subtract it, like from, I'm from factorial, I'm getting 10 value, the m is 15, the remaining is 5. So for 5 I'm going for by the bits, I'm counting the bit. So the 5 value I'm just maintaining by adding 2's powers. Okay, That what I need to do. So the algorithm for taking like all the 2's power 15 cases for the factorial, how can we take it? If you notice it, if we I'm taking a number that is of 2's power 15, let's say for if it is 15, so I can represent here, this is 15 is big for me. Let's say I'm taking a value for 3, for 3 bit, that is 2 to the power 3. If I am having 3 values, okay, so I'm taking 3 bits, that is this 1, 2 and 3. For 3 bits, the value of the different values that I can get in these bits are 0, 1 and 2, 2, then 3 up to 7. Okay, if you observe that, if we taking these values, like I'm having this value, 3 value, okay na, a b c, so how many different ways I can collect these values? Like some, for some scenario I'm taking this and this, for some scenario, all these different values, how many different type of, how many different possible things, so I can take some of these, okay, or all of these, all the different cases, that will be 2 to the power 3. And if I see the value, if I'm just saying that, okay, I'm just making a bit that is running all over from 0 to 2 to the power 3, okay, so it will include 3 bits. And if I'm taking that, like for this, if it is the bit is 0, I'm not taking the value, and if bit is 1, I'm taking the value. Then you will see, observe that this will observe it, this will gonna like cover all the cases, okay. That one gonna do. If like for this case, no one value is there, no value is there, I'm taking none of these. If it is 1, then I'm taking only c. If this is there, I'm only taking b. If these are, I'm taking b and c. These are the cases, okay. So this will gonna cover all the cases, all the 2's power 3 cases. So we are using the only bit set. Let me code, then you will gonna understand more beautifully. Okay. These are beautiful technique, by the way. If you wanna select, like if you wanna select all the possible, if you wanna select something that is the minimum one or the maximum from all the possible scenarios, then using the bit set is very 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 good. Okay. So I need to take in one thing only. And so first of all, what I need to do, sorry, I'm making the factorial. So I will say factor of long long, that is factorial of, it can be 15. Okay. Oh man. So void, I'm calling a function that is fact, that gonna fill up my array. Core int I is equal to 0, I less than, I start from 1.1, and I less than 15, because there are only 15 possible. After that it will gonna jumps out of bound for 10 to the power 12. Okay. Factorial. Oh man. Factorial of I is equal to factorial of, that is a simple algorithm. Factorial of I is equal to factorial of I minus 1 into I. Okay. And I need to define it that factorial of 0 is 1. Okay, here we go. I need to call this function. I'm calling this function here, that is fact. Now my factorial array is completely filled. Now I need to go over all the possible condition, that is from 1 to 10 to the power 15. Okay. Okay. So I'm just knowing which values are set. Okay. I'm taking long temp answer, temp variable. Now, so I have array of 15 values. If this value is set, if I say I, this value is set, this, for this current I will be running from 0 to 10 to the power 15. 2 to the power 15. Okay, if this value is set, I am including in my answer. Answer will be factorial of j. Okay, now if I say if temp is less than equal to, if it is more than, so how, like I can't do that. If it is more than, then how it can't be possible to get into the sum. It can't be possible. If it is smaller, then I will find what is the remaining, and I'm gonna to compensate the remaining with 2's powers. Remaining will be n minus 10. So total cost will be, or total cost will be how many values I taken here. I make a simple count. If I'm taking anything, or it will be simply okay, and plus count of bits. Okay, count of bit that is in the remaining. So what count of bit is, we are taking into 2's power, and answer will be minimum of answer gonna now cost. Let's say long answer can be not long, it is okay, long okay, because I define here long, so I need to, let's most 500, not gonna cross 500. I need to define a function that is count bits. I have long a. Now int count is equal to 0, or int I is equal to 0, I less than, so its value is 41 or 40, something like that. If ai and 1, so this is, if this bit is set, I'm gonna increase my count and return my count. At the end of the program, I will gonna return my answer. Oh man, 2314. Oh yeah, it's working. Oh yes, you can see that it is very simple algorithm, but it is very useful. In many cases, you will gonna use this. It is very beautiful algorithm. I really like this algorithm, by the way. Yeah, it is. I think so. Not really. It is completely fine. Yeah, it is. It is completely fine. Or if it gonna give TLE, so what you will do? Like we are just calling this function again and again for all test cases, but we are not like changing its value for the factorial. I'm gonna call it here only once. But this is 15, so nothing will gonna happen. But if there is, if this value is large, 1 10 to the power e or something, then maybe a problem. Okay, this is the last problem of the day. You are given a set of n is always a power of 2 elements containing all number from 0 to n minus 1 exactly once. Find a n by 2 pairs of elements such that each element is in exactly one pair, and the number over all pair of the bitwise end of its element must be equal to k. Formally, if a, I, b, I are two arrays and a, I, b are the ith value of the pair, then the sum of over all n by 2 pair is k. Okay, so for these type of values, what first we need to find out, how can we make ai bi 0? So what we're gonna make ai bi 0, let's say for all the cases, and on one case is where k a is equal to k, let's say a is equal to k, I'm gonna go with n minus 1 and take out its value. For all other values is 0. So the very important point here in this problem is this one. You are given a set of n, and n is always a power of 2. So for every bit, if n is 2, 3, 4, every bit, like it's say 1, 2, 3, 4, 5, 5. So I am having all different values of 5 bits that it want to say. If this is not case, then we are not able to do that problem. Okay, so I'm having all the different values of 5 for n bits. No, yeah. Okay, so how can be 0? Like AND operator, we have to find the AND operator, that is AI and BI. AND means these bits must be like, if it is 0, then no bits in this are common, no common bit, then it will be 0. So if no common, then I will say that AI is equal to AI, its XOR. What XOR is taken? If XOR is will be uh, with n minus 1, I'm taking then with all set values. All set values will be 2 to the power n minus 1. Like on this value, that is will be n minus 1. Okay, let's say it is 5 bit. Let's say for example for the 3 bit. Okay, 3 bit. Okay, 0. I am having AI, let's say 5, 4 and 0, 1. So I need to something that is just opposite. So for the opposite I need to so that if it is opposite, then end will be 0. So if it, for getting the opposite value, I'm thinking that I'm taking the XOR. So if I'm XOR with this all values. Okay, so what XOR gonna do? If we have same, then it will gonna 0. If it is set in 1 bit, that means if it is set in 1 bit in one of these two values, that means I already said here is all ones, because it is 2 to the power n minus 1, so all 1 will be there, and the 0 will be in this, that is a, though b will be comes out. If 0 1, then it will come out 1. So I will get that is the completely opposite value, and its and will be 0. Completely opposite value means they don't have any common bit. Okay, so and value will be 0. Okay, so we get this. So for if I need to n by 2, okay, and let me show you something, some that I'm taking an example. 0 1 2 3 4 5. I'm taking 3 bit 3 bits here. So values will be from 0 to 2 to the power 3 minus 1, 0 to 7. Okay, now the bit representation of 0 will be 3 bit, it will be 0 0 1. If you gonna see, then you feel it 6 and 7. So first and last, these are something, if I'm taking the end of both of these, then its value will be 0. You're gonna see that. Okay, for all the cases. Okay, so now I need to know about k. Let's say k can be 0. If it is 0, so I know I'm just pairing up with first with last one, and the second with last minus second, last second from third, last third. I'm gonna pair this one, or I will, if I use this algorithm, so I'm running from 0 I0 to n by 2, and for this current I, the b will be, I will pair with I with, that is the XOR of second one, that is I XOR n minus 1. N minus 1 is the last value having all bits set. Okay, so if k is equal to 0, I'm just outputting these, and the value of all these will be 0. Now I need something k uh, n minus 1 or something other than n minus 1. Okay, I'm not, okay. Now the second case is I need any value, any other value. Okay, k is equal to greater than 0 for all values I'm seeing. Now I'm seeing if let's say 3, I need value 3. K is equal to 3, so I need summation of all ai bi, and operator will be 3. So when the value is not 3, so I'm running my for loop from 0 to n by 2. N by 2, 8 by 2 is 4, less than 4. So these four values. If I'm gonna find that So 3 and its opposite value will be that having the 0 value, that is I zor n minus 1, that is 7, and that is 4 value. Its opposite value is, so its n will be 0. So we have the pair now. So these four, both of them having no common value, no common bit. So I'm just running all the loop. When I found that it is 3 or something, 3 or something like opposite of 3, let's say if I'm just getting 6 value, so I'm not gonna run for the opposite of this, that is 1. So, okay, because from 0 to n by 2 1 value will come, that will be this one or the opposite of the pair. So I'm not running for that one, and for all of these the value will be 0, that will be okay. So for all of these value I need the 0. Now I need to somehow need a k. So I have two values, that is k and opposite of k. I will say that is k dash, and sum is 0. I have all, I'm done with all the bits. I have only 2 bits. Now from, like, for all, what I mean that I'm done with all the bits, that is I'm pair up all the bits. Now I have this pair left, and somehow I need to make this so that it will gonna be give me result of value k, summation result of k. So when the value will be k, if k and set with k, and k and operator k will be give me k value, or anything that having all k value set. So I'm 100% sure that n minus 1 having all the value set. So I'm 100% sure that k and n minus 1 will give me k value. Now I am getting k value. Now I have to take care of n minus 1. So n minus 1 pair 1 is 0. So the n minus 1 pair is 0. I am taking out this pair, okay, and I have pair k and k dash. I am pairing with k with n minus 1, so I am getting value k. And if I am making pairing up these two, then 0 and some k dash, that will always be 0, so that's not a problem. So I'm getting the value k. So what I'm doing is I'm just applying the AND operator with 0 with n minus 1. I'm taking the two n minus 1 pair and the k pair, and I'm just matching the pair with cross. So n minus 1 with k, so its value will be 0, and other 0 with opposite of k, that will give me value 0. So the total summation of this kind of thing is k. I'm getting k value now. So I'm now taking the n minus 1 value, n minus 1 pair. Now if k is n minus 1, so the third scenario, if k is equal to n minus 1, then what we need to do? So let's say k is something like that, all values are set. I need to do manipulate or take out the pair or manipulate the pair so that value will be 0 for some pairs and other will be having the 0 values as the same. Okay, so how can I do that? First of all, this is k n minus 1 for 5 bits, and n minus 2, this is n minus 1. So n minus 2 is just a, because n minus 1 having the all bits value set, that is this one, and n minus 2 will be a just a 1 minus. So 1 minus, what will be this one, just a 1 minus. That 1 bit 2 की power 0 is not set, 1 bit is not set. Okay, now this sum will be gonna n minus 2. If I am taking AND of these two, n and n minus 1, this will gonna give me n minus 2. Now, sorry, n minus 2, yes, n minus 2. Now what I need to need k is equal to n minus 1. Now I need another one. Now I am actually I am taking out two pairs, that is n minus 1, the pair of this one, and other pair is n minus 2 comma 1. Now I need something. How can I take the 1 value? Then I will take out third pair, n minus 3 comma 2. Okay, so in n minus 3, let me erase this. Okay, For now here I get n minus 2 value, I need 1. If I say n minus 3, so the how the bit image will be look like. So n minus 3 is equal to n minus 1 minus 2. Okay, that is completely fine. N minus 3 is equal to n minus 1 minus 2. So its scenario is something like this. The second value is 0 and the only the 2 to the power 1 bit will be 0. That will be n minus 1. And I have already have 1 for this n minus 2 pair. And if I take the end with 1, this will gonna be 1 value. Okay. So from I'm taking the 3 pairs, n minus 1 0, n minus 2 1, n minus 3 1. And what I'm doing n minus 1 with n minus 2. This will give me n minus 2 value, and n minus 3 with 1. This give me 1 value. Now all other, what the remaining of the pairs, remaining integers 1 2 0 and 2, I need to, and its end will be 0. Yeah, simply sorted. So 0 and 2 will be 0, and operator of 2 is 0. So it will gonna give me n minus 1 value. But at least we have 3 values, that will be n minus 3. At least we have gonna keep values. So for n start from n is equal to 4. For 4, how many values we have? That is 0 1 2 3. How many pairs I have? I have only 2 pairs, but at least I need 3 pairs. So for if n is equal to 4 and k is equal to n minus 1, it's not gonna work. Okay, so what I need, I need at least 3 pairs so that I can easily manipulate the bits, so to get a result of n minus 1. And from 4 bit onwards, if I am having like the next one will be 8 3 4 5 6, then it having sufficient pair of more than sufficient pair. Okay, so each value is accessible. So you can say that each value of k, we can, for k each value can be accessible. Okay, we can get any value, but we cannot get one case only. K is equal to n minus 1 and n is equal to 4. These values we can't get. So let's code together. If you understand, code by yourself. So what do I am given? I'm given an end in n and k. Okay. So I have make 3 cases. If k is equal to 0, okay, else if k is equal to n minus 1, and another one is that is anything. If k is equal to 0, then I will have to only from 0 to I less than n by 2 and I plus plus, I need to output I with, that is opposite pair, so that its value come out 0, that is I XOR n minus 1. This will gonna output me n by 2 pairs, and all XOR value is 0. The second one is if k is equal to n minus 1, then if k is equal to 4, I say value will be minus 1 and return this. Otherwise I have answer. So how many pair I need? I need 3 pair. So first of all, n minus 1 with n minus 2, sorry, n minus 2 and n minus 1, n minus 3 with 1, n minus 3. Now my value is become n minus 1. Now I reach the requirement, the remaining one will be 2 and 0. Now I have to start from 1 is taken, 2 is taken, I have to start from 3. For all pair it will be 0. Okay, now the last one, I need to copy this, copy paste, and if for anything, if I is equal to something k, or opposite value of k, opposite value will be k or n minus 1, okay, is equal to I will say continue. And for that one, so here is the second case, that is k with n minus 1. I have to take from value start from this one. Okay, so what will be that? K with n minus 1, that will gonna give me value k, and the remaining will be the other value of, that is this one, other value of k pair with 0. This will gonna give me 0, and from 1, okay, I'm done. Let's see, must be working. Oh man, it's, if it is n minus 1, k is equal to n minus 1. If k is equal to n minus 1 and k is, oh sorry, n is equal to 4, that's something, it is minus 1. Okay, here we go. Yes, accepted. Thank you. Thanks a lot.